video, we're going to talk about how to simplify radicals. Now, you might have already simplified expressions, which was the process of combining like terms and removing parentheses. Simplifying expression makes it simpler. Simplifying radicals means something slightly different. So first we're going to talk about what does it mean to simplify a radical. Then we're going to talk about the steps to simplifying a radical, and then we're going to do some simplifying with variables. What does it mean to simplify a radical? Simplifying a radical means to write an equivalent radical which has no perfect squares under the radicand and no radicals in the denominator of a fraction. So we need to define what perfect squares are because we want to get rid of them, so it's important to know what they are. Perfect squares have integer square roots. 4 is 2 to the second power, 9 is 3 to the second power, 16 is 4 squared, and 25 is 5 squared. And you notice how I switched to saying it was 5 squared, 4 squared, 3 squared. That terminology of squared for the 2 is because I can make a square out of 25 blocks. I can make a square out of 16 blocks. Okay? Now, when I take the square root of these, I get 2. The square root of 3 squared is 3. And of course, the square root of 4 squared is 4. And the square root of 5 squared is 5. Because the square root of 25 is 5. And we get nice, pretty numbers when we take the square root of perfect squares. We don't get decimals when we take the square root of perfect squares. Non-perfect squares, ones that we take the square root of, for example, 32. If I take the square root of 32, I get a decimal, a very long decimal that goes on forever, and that means it's irrational. And irrational numbers can sometimes be simplified. So sometimes when you have a square root that is a decimal that goes on forever, you can simplify it. Sometimes it has a perfect square factor in there that I can take the square root of to make it simpler. And that's what we're going to talk about in this video. Let's look at how you simplify the square root of 80. So if I do the square root of 80 in my calculator, I get 8.9442717, blah, 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 blah. That's a decimal that goes on forever. It's truncated here, which means the calculator can only put so many decimal places in there and then it stops, but it does go on forever and ever. So this is an irrational number. It's not, when it says to simplify, it doesn't mean to do this. If it wants you to do this, it's going to say find the square root of 80 or evaluate the square root of 80. If it says simplify, what it wants you to do is find if there's any perfect square factors that you can take the square root of. So here's how you do it. First, you're going to find the prime factors with a factor ladder. So I'm going to do that really quickly. Okay, when you get to 1, that's right, you're done. So I found the prime factors with a factor ladder. This was step 1. Step 2 is to write it as a product of primes. So 2 times 2 times 2 times 2 times 5 is 80. That's the significance of those numbers. So I can write it as 2 times 2 times 2 times 2 times 5. That's the same thing as 80. You can check it right now if you want, but it's the same thing as 80. For step 3, I'm going to find the square root of all my perfect squares. Well, I'm going to pair these guys up with numbers that are the same. And I'm going to take the square root of each one. The square root of 2 squared is 2. The square root of 2 squared is 2. And the square root of 5, I can't do because he doesn't have a partner. Sad, he's not a perfect square. This is step 3. Find the square root of the perfect squares. Perfect square, add a perfect square. And then we multiply what's left. So step 4, 2 times 2 is 4, square roots of 5. And it's simplified because underneath the radical, I have no more I have no more perfect square factors. 5, the only factors are 5 and itself. And none of the factors are prime. So this is simplified. Let's look at one more example. This time we're going to mix it up and we have some variables and we have a cube root. So I've changed the steps here, just one little thing. I just put find the root of perfect roots. So if this is a 3, then instead of looking for things to the second power, I'm looking for things to the third power. Okay, but I'm still going to start off the same. Find prime factors with factor ladder. Here we go. And it's always a good idea at this time to check and do 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54, just to make sure that you did do this step correctly. So this was step 1. Step 2, write it as a product of primes. And remember that this is the cube root that we're finding this time. Now, I also have 5 A's, and you might want to write them all out for right now. Oh no, I'm going to run into my steps. It's fine. But in the future, you might be able to just envision groups of 3 because that's what we're looking for, right? Okay, so 2 doesn't have a group of 3. Even if it had another 2 here, I wouldn't pull it out because I'm looking for a group of 3 this time. So I'm going to put them into groups of 3. So the 3s have a group of 3, and this group of A's has a group of 3, and then there's 2 A's that don't have a third partner, and then I have a group of 3 B's. So I'm grouping them together into 3's because this is a 3. Before it was a 2. There's always an understood index of 2 there. Okay, so this was step 2, and then step 3 is to go ahead and find the root of your perfect roots. So I can take the root of this, and I can take the root of this, and I can take the root of this. And then everything else is going to be on the inside. So there was a 2 that didn't have a group of 3, and then there was an A squared who didn't have another A to be grouped with. And then multiply the result. But I don't really need to do that because it's already multiplied. So that's my answer.